forgot to skip over here too, because y'all gonna start programming. We should have done this first. And we can always come back to this. And we'll look at the one about revised rules for PLC ladder logic using RS Logic 500. Of course, if you notice some of these rules change. They always work. I mean, every PLC I've ever programmed, these rules work. So if you learn these rules, then you don't have to worry about, okay, does that work on this PLC and not on that PLC? So they all work. Rule number 1, error that will not clear until corrected. Input instructions must be placed between L1, the vertical rail, and the rungs below. It should be noted that any instruction that RS Logic 500 automatically shifts over to the left-hand side, these are considered to be input instructions. Now this is RS Logic 500. Other programming applications don't do this. RS Logic 500, if you try to insert an input over here by itself, it automatically moves it over to the left. Are we okay on that? So that means if I come over here, now remember RS Logic 500, you start off with an error, right? And it stays there until you do what? Until you check it. Well, I'm going to come over here and put a contact right there. So now I've got a contact between my lows and L2. And I got an error, right? And it won't what? It won't clear, but it's going to tell you something's wrong with it. Rule 2, an error that will not clear until you correct it. Output instructions are placed between the rungs to control devices and L2, the right vertical line. Nothing is allowed to run output instruction in L2, the right vertical rail. Any instruction that RS Logic 500 programming language automatically shifts to the L2 side, these are considered output instructions. Rule 3, we don't have to worry about these. It's in the textbook, but it's automatic. Rule 4, error that will not clear until corrected. A rung's output instructions must not be placed in series with other output instructions. Multiple rung output instructions can be placed in parallel in another line. And that's where this guy falls behind. Somewhere in his rules, he says one output per rung, and that is false. We can have multiple outputs per rung, but we have to put them in a different line, right? Everybody understand that? Multiple output instructions can be placed in parallel in another line. One output instruction per line, one or more output instructions per rung. There is no multi-load series or parallel circuits allowed. And this is also true in motor. Rule number 5, error that will not clear into correct code flow from L1 toward L2. So you don't want to put a drop down and send the signal back toward L1. Rule 6, we don't have to worry about this. Rung numbers are automatically placed on the left-hand side of the rung's first line. Rule 7, this is user-defined. This is not automatic. Each input or output instruction's address must be entered above each instruction. The location and syntax is predefined by the ladder logic programming application. Note that RS Logic 500, once a logical address for a bit instruction is entered at the top of the symbol, the bit address will shift below the symbol. A block input or output instruction, so when we get to the counter, the actual address will be entered inside the symbol. So we'll have to learn the syntax for that. And this up here only applies to inputs and outputs that we're using now. Output enables and then output input examine if closed and examine closed. User A, user defined. Optional comments and symbols should be added to each instruction symbol and rung. RS Logic and Siemens, these are called these are called tags or comments instead of descriptions. The comments are called descriptions and the symbols are called tags. User defined, not automatic, optional RS 500 required for this course. Instruction symbols or tags should be given a name that relates to the instruction function and control. So use of symbols allows the assigned numerical address to be addressed by name instead of number. Tags are required in Logic RS 500 and Siemens S7 and TIA4. This was Siemens 7. It's actually integrated with what we call total integrated automation control TIA4. These guys right here, you don't like addressing in this guy. Wait till you get RS 5000 or Studio 5000 or Studio Design. It's hard to get that syntax right, so normally we just select it out of the list. Input and relays, output enable contact instruction multiple times within the program. This is true. I need to go back and change. We can use output enable addresses multiple times, but it's going to give you a problem. I showed y'all that, right? Now let's trace that to y'all. I know it is, because the program's still here. So let me check this, make sure it's okay. I'm going to come up here and go ahead and download it. PLC. So what I've done is I've duplicated. I'm going to duplicate an address. I'm going to duplicate one of these addresses right here. So output 4, let's go ahead and change this to output 3. It won't. I'm going to bring another output instruction down. And I'm going to call it output : 0/3. Check it for errors. So if you don't put symbols are optional. But like I said, if we use symbols, then we do what? Then we can use the symbol instead of the name. Alright, we'll download this one. Oops. Did I do something wrong? There we go. What's going on with my PLC? Download here. No response from the processor. I didn't read my email. So I'm going to go up here and I'm going to look, see who's online. My PLC is offline. Oh. Let's go that together. Well, my PLC offline. I ain't connected. offline. It's browsing and looking for it right now on this node right here. Dang it, Rich. So right now, I'm going to come up here and energize switch 0. I'll turn it off because it's, and notice this guy energized, this guy energized, this guy didn't. Why? Well, see, I've duplicated this address. And the way the PLC scans, it does this guy here, reads inputs, runs logic, updates outputs, reads inputs. And the problem is, reads inputs, this is down below that one. So this input, this takes precedence over that. So here's output 3, there's output 3. This rung is telling output 3 to turn off. This rung's telling output 3 to turn on. But since this is down at a rung that scanned last, it's the one that takes precedence over. So now I can come over here. Sure, I can control that one switch. Yeah, but it'll never work. That's why, because this guy is what? So that's why legally, but I got no errors, right? You understand? Because it's in the right syntax. But and it's not going to get that. We're not going to get that error, and I'll show you why. Because we got 2 instructions we can duplicate addresses on. That's these outputs right here. One of them's called latch and one of them's called unlatch. Output latch and output unlatch. And these are going to have the same address. So that only works for this instruction right there, or when we get into timers or anything like that. So the way the program's written, that guy right there can never work. So if you do a program and you got an output where the rung appears to be true, so that means you got one path up here where all these switches have green around them. So if that's green, it means signal flow can get through it. If they're all the way to your output and your output is not energized, what does that probably mean? It probably means you duplicated what? The address somewhere. Usually don't occur in this class because our programs are so small, but when we get into, if you take PLC 2, the programs get more complex, and it happens every once in a while. So this is true, but we shouldn't do it, right? This will not cause an error. Output instruction addresses should only be used once. I'm gonna go and play around with those things. It's legal, but it's a problem. Output instruction addresses should only be used once. This does not apply to the latch and unlatch output instructions. The latch and unlatch cores will have the same address. We're going to deal with those this semester. This is why this will not cause an error. The use of the output instruction address is only allowed if the original rung is exactly duplicated in the last rung is determined by the state. So if you use an output and it's not exactly, I need to go back and reword that one too. That's not true. So that's 11 rows. Everybody okay with those? Y'all going to abide by them? Yes, no. I gave them out. I handed it out to him last time. You should have a handout. And it's online. It's in Blackboard under handouts. So we'd already started on this. I told y'all structured text, right? And these different programming languages that we can use. These are actually symbols. These are IE. So international signals. So we got ANSI, which is American National Standard Institute. And basically, they started a lot of stuff. So a lot of the symbols that we use was developed by ANSI. Then we have IEC, which is the International Electrotechnical Commission. And they don't use a bunch of symbols that we use. Most of the rest of the world has adopted IEC. So we're in a situation where we got to basically look at both of them. So one of the handouts that I gave y'all has the digital symbols on. This is function block. I'll try to demonstrate these. The only programming language that RSLogix 500 supports is Ladder. But Studio Designer and TIA Portal both support. They support. One of them supports this language. One of them don't. They both support function block diagram, and they both support sequential function chart. And none of them I've ever seen support the language. It's too hard. This is where we actually started with the relay rules. This is what I gave you out. So this is what we got down in here, right? The book actually gives you the illustrations of the comments. This is actually directly out of the one of the portion of one of the programs that controls the Festo. So these are block instructions. We're not going to get to those, but we'll get to those if you take that's a one-shot rising. So we're not going to get that. These are advanced instructions. That we only get into advanced instructions if you take the next advanced. We also get into this too when you in PLC 3 because when we do PLC 3, we literally take these programs and convert them over to the TIA Portal programs. So we'll have to get into the one shots how they work. We know about starting a PLC program, right? So a lot of y'all missed that, right? So on this one, when we start a program, we have to do what? We have to start by configuring the communication. A project. Know how to find addresses? Everybody okay there? Yes, no? Offline. So we have offline. So these are the modes that the PLC can be in. They can do what? I'm sorry. This is the mode that the application can be. So the application can be what? Online or offline. When we're online, we have the ability to monitor the program, right? When we're offline, what can we do offline? Change the program or create the program, right? Now the PLC has 3 modes. What's the 3 modes? Run, program, and remote, right? Everybody understand those 3? Yes or no? You're going to sleep. Go out there and spend it in the car, go home. That bothers me. Now, if you already know this, come up and see the platform, I will allow. Okay, we already been through this. We want to go through this. We talked about this examine if open and examine if closed. That's probably one of the hardest instructions for this PLC to understand. When do you use that symbol? And it depends on the logic, what you're looking for. But when you're in this diagram and you come over here and you see something that looks like this, That's a normally closed limit switch. What are you going to use in your program? Examine if open. That's exactly right. And this guy has a problem with that. So look what he's done. Here's the program, right? No, he don't. Let's see. Does he show it? No, he don't show us the program. But he's going to do that every once in a while. He's going to show you the actual physical circuit. And he's going to do the program for you. And he's going to use that symbol. He's going to use that symbol for normally closed. Program contacts that are controlled by runs outputs are simply called normal. Even though the instructions are examine if open, examine if closed, we'll call them normally open and normally closed because that's the way they operate. If they're in the program, if they're controlled by an input, now this is when you're concerned about examine if open and examine if closed. If they're controlled by something, you hook up to one of those inputs on the field. So RS links, this is what we use to do what? Install the correct driver. Y'all not going to have to do this. But what's a driver? In computers, what's a driver? Yeah, that does what? Controls hardware. So what's hardware? If you can touch it, it's hardware. So everything we're doing, so that PLC, those outputs and inputs, that's all. This display is hardware. I can touch it. Well, there's got to be a program to make the display work. So that's what your operating system is. An operating system is basically thousands of drivers that controls everything in there. And then you have what we call a shell that allows you to control the operating system. So the shell for Windows is called Explorer. It allows me to go and click on icons and load stuff like that. That's the shell. That's the shell for that. So usually an operating system has something that allows the programmer to control the operating system. If you don't have a driver, so our computers didn't have a driver for that. So what I have to do? I had to install the driver. Now, once we put it on there, it works fine. Install the correct driver for the message. So the drivers are already there. It's inside that RSLogic 500 folder, but it's not going to load all those drivers into your computer because if you're only using one, you don't want to take up that memory space. It's just like down here. When we come up here down here and we come up here and say symbols, it's like your phone. Emojis use this many bits right here. So it uses 20 bits for emoji code. So I mean, technically that could be 2 to the 20th bits that holds that graphic image for that emoji. So do they give you all those emojis as available? No, because you've run out of memory in your phone, right off the bat. So every once in a while they update them, and sometimes they modify them and change them. So they say we have a new set of emojis to load in. So in here, these codes for these characters and symbols and everything. If I come over here and if I insert a symbol, it uses 4 hex digits. So that means there's 65,000, with this right here, there's 65,536 codes that holds the graphics pattern for all these symbols. You think Windows loads in all 65,536 of those symbols? No. So you have a lot of blank spaces. So if you go through here, you'll see it jump. This is called Unicode. Because we would run out of our memory in our computer just to hold the graphics pattern. So these are graphics patterns. So when I put this code, and they know when I put so when I put this code right here, code that goes in, that's the code that's inside my document. And you know, this code goes into the memory, pulls out the traffic patterns they go. You think that takes a lot of space, right? So that means we don't load, we only load in the drivers that we're going to use in our slow code. Install the correct driver and then configure the driver. What's nice about ours is that when I do it, when I select the DX485 driver and I've got that module hooked up for me, they want to do that. They want to do that. So what's nice about this guy is when we install that driver, so configure driver. So this is all the drivers this guy right here supports. It's on this list right. Yeah. Yeah, if we wanted to load in another driver, these are all they support. There's a DFI driver, there's an Ethernet device driver, Ethernet IP. Now I've got Ethernet IP on this computer because we use it when we run the 214s. But on the DFI driver, on the 485 driver, if I go and configure it, all I have to do is figure out what COM port it's on. And there's a lot of them, guys. So if you didn't know it, you could literally go through each one of them and keep trying to configure it. But we can come up here and auto configure, and it comes up and does it for us. But to find the COM port, I had to go to Device Manager and see where it put it at. So all y'all are on different places. So when you go and look at that, you're going to be on a different COM port. Some of them was on the same COM. Now Ethernet, we have to assign in an IP. So once we load the Ethernet driver, we have to load in DHCP, boot DHCP. And we'll if you take advanced PLC, that's what we'll do. We'll go through how to set up what we call the IP address. So there's a lot more to it than meets the eye. And that's what I really like about the TIA portal. It does it for you. Because it only uses, now if we brought in a module that supported these other interfaces, we would probably have to load in a driver for those. These 485, Ethernet, boot, we talked about that the other day. This goes through it. This is syncing and sourcing. Everybody okay on those? So our PLCs are wired, it's running syncing inputs. That means our PLC, this is going to be a plus. So that means the PLC is a minus on this side, which you can't see. And it's running sourcing outputs. So that means this is a plus on the output port, and this right here has to be a minus. So that means when you come up here and you draw your diagram like this is what you're going to do. So you're going to mark out that 120 volts. You're going to mark that out. You don't have to write common in there. And what we're doing, so the plus is going to come up here and go out. And then you're going to run a common down through here as far as you need to go. And then you're going to come up here and you're going to hook up the devices. Now this goes to the PLC, and so the PLC inputs are running a minus, and that means I have to put a plus. I mean, if I come over here and I use a sensor, then I'm gonna have to make sure I use a PNP sensor for this guy. We're running sourcing outputs, so notice the plus is hooked up to the common on the PLC. You can actually see that on yours. You can see the red wire with the red stripe if you look at the bottom. And then it's got a jumper that moves over. And then this guy here would be a common and it would run down. This guy does that. Normally this would run all the way over. So this is the way you're going to draw this. So this is what you're going to do this semester. You're going to draw the way you hook up these devices. And I will, during the semester, we will hook this up. And if you got one of your circuits, you want to hook up the devices, we can do that. So we got these panels right here. That you're more than welcome to use. Don't do it on your first lab, but later on you get into so we got these guys right here. So we got analog. We can simulate an analog. This is a inductive sensor. Then we got some push buttons right here you can use. We got some switches. And we've got, this is actually an encoder. So what we would normally use with this is we would hook up just a DC power supply where we control the speed. And this encoder, I don't know if you can see it or not, but it's got a bunch of little slots in it. And when it spins, it goes to the sensor right here, which we'll talk about. And it will get a pulse for every one of them. We can use that to sense position, but we can also use it to sense speed. We won't use that this class. And this is our output box. And these motors are small enough to run directly with the PLC. This is set up with a reverser, so that's the reversing relays right there. So we can actually reverse this one. And then we have some lights that we can turn on. You're more than welcome, like I said. But don't do it on your first few labs, just one of them down the line if you want to do that. And there's one I'll hook up for you to show you how you would hook up your sensor. So PLCs are really easy to wire because you're not concerned with hooking up switches in series or parallel or anything like that. You're not concerned with hooking up loads like that because all that's done with your program, right? You understand? So you hook switches in series. Of course, we don't hook outputs in series. That would give us some problems. This is a PLC diagram, so I sent this out to you. So this is actually a diagram of a using IEC symbol. I gave those to you too, right? Did we give those out to you, those symbols? Yes, no? Symbols. On the handouts we got. Yeah, those. On the back you have electrical symbols. This is what a lot you'll run into in here. Then we got IEC symbols. These are symbols that you might run into, depends on where it came from. And this is the way a lot of drawings are done about how we wire the actual PLC. Oh, wrong class, hold on. Now, the problem we have is that these electronic sensors, no, that's the panel, sorry. And that was the pneumatic circuit. So this should be the one that I've got there. So this is the input to PLC. This is 0 volts. This is a minus something. That's a plus 24 volts across the top. This wire would be brown. This wire would be blue. This wire would be black. This singular source. Now this would be what on your symbol record what type of sensor. What type of symbol for it? That's the L symbol. We have it right. Yeah, these are all instructions. But the category. So basically, category sensors are contact or non-contact. Except that the non-contact sensors. Somebody. What type of sensor is this? That's the category. That's like I said, what kind of vehicle do you have? I have a car. Yeah, this is a big. So it's got a 50 mail. Thank you, no problem. So this it's electronic sensor. We have to power it up. I don't care if it's thinking source. Got to power it up. So this is plus minus. That powers up the sensor. This is the input. See, it's going to be black. I don't know what it is. Well, I don't know this thing in the source. What I'm going to do is I'm going to look at this thing switch right here. It's connected to the plus, so it's going to be some provide plus. So these sensors have got to be sourcing, right? You understand? So this is the sourcing switch. We got no options. They don't have to. So yeah, you can't tell that from the solid state. You can't tell that. No, this is a 2 wire sensor. We don't have to. We have some politics. Politics. You don't know if it's on plus. These guys are here everything plus. That's plus that one. That's what what you wire. And that's the one thing you need to know. Because you can't get, you got the part number for the sensor. Make sure you look up that part number. Don't just go to that company and buy a sensor. Those odds are they make it in both what? Thinking and sourcing models. Like when you buy a car, you know, it might be 2 different colors. So you want white and black, so it's the same type of car. So you have to make sure you figure that out. Or look at the diagram, find something that's not electronic or does not require power, like power. Obviously, power is important. That's the plus. Plus comes down to PLC has to be thinking, right? we're talking about plus or minus. If the PLC is syncing, then my sensors have to be sourced. You probably saying that right. If my PLC is sourcing, then the PLC has to be sensors have to be syncing. So they have to be opposite. So the sensors have to be opposite of what the PLC inputs are wired to have. So, like I said, some PLCs you don't have that option. Some PLCs, our PLC here, if you look at the top, we got two commons. It does not say plus, it does not say minus. So what we're doing is we're setting up a common for the PLC. So I have a minus running up there. So I've got a minus running to both of the commons, so that means I set that PLC up to be essential. So on this one, we can set it up in what's the first one? The first one is like 5 inputs, I think I can set up one way. Now down on the outputs, those are relays. Relay contacts don't care. So if you look at the outputs of the PLC, all they say is AC DC. So I could on this PLC I could set up a contact here as sourcing. I could set up the one next to it as syncing. I could set up the one next to that as AC. So that's the big advantage of a relay output, is that you determine whether you want syncing or sourcing or AC or DC. The biggest problem with relay outputs is they're electromechanical devices, which means they can do what? They can fail 2 different ways. And another thing is how fast they can switch. So normally, probably 99.9% of the time, it's fine. But when we get into things like pulse width modulation and stuff like that, to control the speeds of motors, these guys right here just can't. Ain't no way in the world they can keep up with that. So that's where you'd have to make sure you had solid state output. Yeah, so this I just wanted to show you, but these are IEC samples. So a lot of our companies around here are going to use it because well, this is what most of the world uses. Over here, a lot of or you might be using ANSI symbols, because those are American National Standards. So who set up all those symbols? We did, right? So it's like ASCII, American Standard Code for Information Interchange. We were the first ones that figured out how to send information, actual text and stuff like that over wires. And we came up with that code. Morse code. Who came up with that? We did, right? That's an international code. And that's why when they went to Unicode, the first 250, the first 128 codes are just ASCII codes. They just use 16 bits instead of the 8-bit code. So this is what you're going to do. You're going to draw these symbols. What we do. So let's take a quick look at our lab and make sure. So what's our first lab we wire up? If you don't have your lab book, you might need to slide over and get one. Y'all going to have your lab book next week, guys. Let's just look at 23. Page 23. Yeah. This is 6.2. I think this might be the first actual one we programmed. So notice they're giving you the relay logic, and then you're going to take that and draw this out, right? But if you look on the next page, on page 24, they give you the program down at the bottom. Now this is where they start off, right? Now eventually they're going to take the program away and just give you the drawing. You have to come up with a PLC program for the drawing. So everybody's program should look exactly the same, because they do what? They give you the program. Everybody understand that? And they assign inputs. Y'all see that? Now on page 25, this will be activity 2. They don't give you that program. I have no idea. Anybody bought one? Probably. It's the same book. It's just mine's a different color. That's a good deal. If you take both classes, it's a good deal because that would only be. Well, the PowerPoints are really detailed. Y'all probably noticed that too. So until you get them, we can use the PowerPoints for that. But there are some things in the book that it's always good to get things from multiple directions, right? Does that make sense? Sometimes it makes the different perspectives. That's what I'm trying to. Yeah, I don't even know who the manager is. I don't either. I know the guy that was over there left. Yeah, that's what we'll use that for both PLC 1 and PLC 2. Even though PLC 2 moves over to a different application, all it is programs. They said, okay, you want to write a program to do this. And we could do that on any PLC. Yeah, if it's used, need to check to make sure it has these labs. Because like I said, you tear these out and you turn them in. So if you buy a used book, odds are some of the labs are going to be gone, right? Oh yeah. I would do that to all my academic books, but all my technical books, I still have those. We went out to CMC Steel into the electronic repair shop out there, and up on the shelf was the motor control book. So that's a good book, guys. That's pretty expensive, but it's still. But if you look on page 26, that's where you're going to have to start marking stuff out, which is wrong. So this is what they've done. This is what that guy's done. You're going to mark this out. You don't have to write common up there. The common's okay over here. And then you're going to draw that out and draw that power supply the way we've been showing y'all, right? We're running sinking input, so the minus has got to point toward this way. And then we're running sourcing output, so the plus. So those batteries are going to be pointing, the minus is going to be pointing toward the left. I mean the right, I don't know the difference. Y'all know what the minus symbol of a DC source is, right? A DC source, this little small one, that is the minus, this long line. This is a symbol for a DC source, period. Whether it's electronic or whether it's chemical, that's the same symbol we use. So that means you're going to mark this common out. You're going to draw a wire out here. You might have to bring it up because this guy right here gets pretty close sometimes. And then you're going to draw the negative toward this. And over here, the negative is going to point out. Because we're running sinking inputs and sourcing outputs on our PLC. Sourcing outputs, sinking inputs, sourcing outputs. This is minus, this is plus. It depends on how we hook the battery up or the DC source. So on this one, we're going to point the minus toward that dot. On this one, we're going to point the plus toward that dot. And then we'll talk about another problem that some of y'all don't have y'all to do. We'll talk about. We'll talk about that. So good gracious, guys. Maybe we need to. This, I don't know what page this is on because all I have is the Logic Pro Lab. But this is a light bulb, and they've assigned a contact to a light bulb. Does light bulbs have contacts? No. So you need to get rid of those lines. See what I'm talking about? So that's the symbol for a light bulb, and then they assign a contact to a light bulb. You can assign a contact to an output or a relay, but you can't assign one to a light bulb. I've never seen light bulbs with contacts, and that's the only problem you have. By the way, once you put that down drop in there, you can put multiple devices inside that down drop. I mean, you can put as many as you want to inside there. I think I've got that done on my program. So I could literally I could input devices. So I could put stuff in there, right? You understand that? Mm-hmm. And that's what that's done. And usually what we do is we bring the down drop and then we slide stuff in. And if your diagram gets too long, then it's going to automatically drop down like this. And if you want to see it, what can you do? You can come up here and click on this little minus sign and it makes it smaller. Or you can come up here and grab this and cover up your project tree. But don't delete your project tree because it's hard to get back. Are we okay? Don't do that. You can actually untether this power. All right, guys. I'll be around, so I'll be checking on y'all next class. Like I said, I'm gonna see if Miss Wilson can come over here and do this for you. RPLC.